castle where the digital dreams come alive. CESCG takes place from May 1 to 5, from visualization to the virtual space. Scientific sessions take their place.
Hello, dear colleagues. My name is Anastasiia Lebedenko. I'm from Brno University of Technology. And under the supervision of my mentor, Adam Herod, I was working on my bachelor thesis called Optimal Crop Out for Photographing People During Sports Activities. So as you have seen during the fast forward, the principle of my solution is that you have a big video where the person is moving and you want to crop out a small video where the person is nicely centered in the video and no parts of the body are outside of the crop. So this is the result. But first I will start with some problem definition why we do this. The exact situations where you can apply this program will be more defined in the evaluation part, so hold on to that, because my task was basically to experiment with the different crop modes and to find out if it's usable or not. The initial task was, you have beautiful videos of people that are doing sports, that are doing some tutorials, and they're beautifully centered, so this person is like almost perfectly in the center of the video. And for example, this person has set up different cameras to capture her in full size and also capture her feet when she was teaching the tap dance. And it takes a lot of work. You need to set up your camera, you need to walk away from your camera and check how good your dimensions are. And sometimes, especially when you're moving, you don't know where exactly you will go during the video. So sometimes it takes a lot of editing after filming and cropping so that it looks great. And my supervisor had this problem, and he wanted to basically film a very large video on some good camera and not take care of how he will look like in this video and just crop it afterwards based on different settings. And the problem was that there are almost no programs that can do this. The interesting state-of-the-art solution, I would say, is Center Stage in iPads and MacBooks, some of them. Only some devices that have Apple's ultra-wide camera. You see the frame that is already cropped, but the input to this ML model is some wide footage, and it tracks the person, and in real time it changes the crop of the frame. And it's good because now I face the camera and it moves to me, but then I also face away from the camera and it tracks me. It's not the open source solution, so I don't know exactly how it is implemented, but you can see it's not based on the face detection, it's based on some human detection. And it's not possible to use this program to process some already made videos. It's possible to use it only in real time, like in FaceTime or Zoom, and it's written in the hardware, basically, of this device. It's not open source, and also it uses ML model to crop every frame. Then the interesting solution that is most similar to my solution, but not quite yet, is from Cloudinary. So it provides the API for cropping videos, and you can set up some parameters. For example, you have a video that is not high enough, like not tall enough, and you can just add blurred background. You can set up the width and height. You can also keep the right half of the video. So it's not like intelligent algorithm, it's just like basic cropping, but this one is auto crop with the focus and faces, so it uses some ML models, and they call it gravity towards faces. So it uses some face detection, and you can see on the original videos, their faces are like fully in the frame, but here it's in this, their faces are in the center of the frame, but they can be not fully visible sometimes. And this is the problem, because if you want to film some videos where you teach how to do some sport, you want your full body to be visible, and the whole point is that you don't crop the part of your arm or leg, because at first it doesn't look nice, and the second you just want it to be the optimal crop. This cloudinary solution uses also ML models. My solution uses ML at some point, but I have decided to do the crop using some basic math algorithm, basically, and do the human recognition in the first stage that is executed only once per video. So I start processing my video. The initial processing stage uses some existing human detectors. I will talk about them later. And then the user can set up some crop settings that can experiment with them. And the crop of the video is almost immediate, because it's just going through frames and cropping them. So it's not using ML at this point. So, in detail, how the pipeline works. You have the original video that has some big frames, and you can choose if you want to use the media pipe or YOLO detector. And I will tell you later why I used exactly those two. But for example, you have media pipe, and it's the pose detector, actually, a pose estimator, and it gives me as the result the landmarks. And for each frame, I have exactly 33 landmarks of the person that has X and Y coordinate. And based on these landmarks, I form the bounding box around the coordinates, the landmarks. And in case of YOLO and other typical human detectors, I just take the bounding boxes that the detector gives me. And I save this data in the JSON format so that I can use it later, so that I don't process the video over and over again each time I change a crop setting. What's the difference between bounding boxes and frame boxes? Frame box is the actual coordinates of the frame that will be in the output video. It's formed based on the bounding boxes. The bounding boxes have, of course, different X and Y coordinates. It's like the top X and Y coordinates, and they have different width and height, because the person can spread their hands or sit down. So the size of the person can change, and these parameters can change. But if you want to crop the video, of course, you want it to be the static size. So I take the biggest width and height of the bounding box, and I just declare it as the global width and height of the optimally cropped video. Of course, it can change with the different crop settings. So I can set up the aspect ratio and padding and so on. For the frame, I set up the top X and Y coordinate in the way that the bounding box is perfectly centered in the frame. So it's also not hard to do. Just to center it and calculate the top coordinates. And based on the crop settings, I calculate the frame box, and then I apply to original video, and I receive the cropped video. The detectors. I used the existing detectors because YOLO, for example, is one of the most exact out there, and I just want to use whatever is available, and to focus more on the cropping of videos, not to develop some new human detector that is probably going to be worse than YOLO. But I started with the media pipe pose detector. Why? Because I saw some detectors that are giving me the bounding boxes that have some redundant space. So it would not be good for the optimal crop. So I started with the pose estimate, and I wanted to get all the key points and get the bounding box, because if you are already detecting a person with the pose key points, you know that you just crop the key points and it will be exactly that, like the dimensions of the person. There will be no redundant space. And MediaPipe is great at detecting one prominent person. So if you want to get the video of a person with some people in the background, it will do a great job in that. But I have found out that, of course, you can see that the key point of the hand, for example, is here, and the tips of the fingers are here. So it's not the perfect bounding box. So then I used the segmentation mask, and now it gives like really perfect bounding box around the person. And then when I submitted the paper to this conference, the reviewers advised me to use YOLO, which is obviously a great idea. And it detects multiple people, it detects objects, it returns just the bounding boxes that are pretty exact, but it's not good for the prominent person and the background, because then the detector just loses their mind and they detects like people in the background, and it's not that exact, but you will see in the result. When we go to the crop modes, I have experimented with different videos, and my task was basically to find out what is the best suitable crop modes for each video. And for example, here my friend is walking on the slack line, and here you can see the first frame of the video and the annotated frame boxes for like every 60th frame. And you can see that I had the vertical constraint, so that my friend, he has mostly horizontal movement, so it's mostly horizontal. And here I don't put any constraints, so the person can jump in these directions, and it's no need to do some vertical or horizontal constraints. And here people are doing acro yoga. I have found out that you don't want to track them when they make these little movements, because yoga is very stable, and it actually distracts you when you just move your crop just a little bit every time they, like shift to this direction. I have this crop mode of just a fixed area, so that you can, for example, have video of smaller dimensions, for example, for mobile phones, and you don't see this redundant background. When I have the pose key points, of course, I can experiment with cropping just some specific body parts, like the woman with step dance was doing, just to show the legs, to bring focus to this part of the body when teaching, to crop the sports equipment with object detection, and to, in some sports where you interact with other people, I'm not talking about team sports, but for example, like curling or boxing, where you're close to another person, it makes sense to crop both of you. So now we go to the results. Here I have the video of acro yoga. It detected two people together, and it uses the fixed area crop mode. So you can see that the results are really optimal. The frame didn't move, right? It just cropped out the redundant surroundings, and here you can see that these three frames defined the dimensions of the optimally cropped video, because here she almost touches the edge, but she never gets out of the frame, and neither part of their bodies never went out of this. So it was the maximum point, and the same thing here, and the same thing here. So the crop, I would say, is optimal. And the next video will show the dancing with some people in background. It was using the MediaPipe detector. You can see that the pose estimates never went to the background, and the person is nicely cropped. And so I used the MediaPipe, but I used the segmentation mask here, because the landmarks don't give the exact crop. It's just some hand can be cropped, or the head. And with sporting equipment, here is the demonstration of a person on the bicycle. And I have also implemented the crop mode so that the person, for example, moves further away from the frame, but here he remains, like, it seems like he is the same distance from the frame, from the camera, sorry. So this is just cropped without the zoom mode, just optimal, and this is with the zoom mode. I have tested my outputs on the potential users, and it was not like I have developed the whole program and then tested it. I was iteratively improving it. So on the very first stage, I have cropped the frames and just put it together in the video, and I didn't even need users to test that the video was jittery, it was shaky. Not because the detection was not good, it was good, but when I have been stabilizing the frame boxes, maybe it was some pixel differences that made the frame look like this. So I have applied not stabilization, like not normal stabilization that you would do in the videos. 1 minute, okay. So I do the filtering of just the array using self-goal filter and outliers detection. And I have focused then that some videos, users told me that they're great in the full size if you watch them on the laptop. But I have focused on processing these videos for mobile, where you need this the aspect ratio, for example, 1:1 or 9:16, and you need to see this video, and you don't want to zoom in each time when you have a good horizontal video, like in YouTube. And when the hand is close to the edge, for some users it was a little bit annoying because it was such a good optimal crop. So I have added the padding option. Thank you for your attention.
Thank you very much, Anastasiia, for a very nice presentation. So now it's time for your questions.
Hi, nice work. So I was wondering if your requirement was that you do purely, forward sort of reasoning, or if you can look at the whole video sequence in retrospect, and then, for example, if a person is moving a lot to the right out of the frame, maybe you would know that the optimum is sort of advancing the camera in the same direction more rapidly in order not allow for the person to fall out of the frame. If you know the future because you have seen the entire video sequence, could you do a better job?
So if I can predict where the person is moving, like the direction of the movement, when I crop videos that are already filmed, so I go through every frame in the first stage, and I already know where the person is moving. And then I just crop based on these dimensions. It would be nice to predict, but you mean it would be useful for the real-time crop, or?
Well, this would be my next question, right? If you have the entire video sequence, you can globally optimize across the entire video sequence.
Mm-hmm, yeah? Mm-hmm. I have focused on the cropping the already existing videos because it was the whole point, like with the crop settings and everything. It is interesting to crop it in the real time. I have tried it also, and it's not hard because it depends on the crop setting. Because if you have the full area, you don't know what is the full area where the person will be located, and you can never predict that because humans are unpredictable, I think. But you can predict the movement, I think, if the person starts moving in this direction. Based on some training on some different sports, you can predict what would be the range of movement. But if you apply the crop setting of, for example, just moving the frame freely with the person and zooming in and out, it is not needed to have the prediction because you just crop it and stabilize. Yeah, but there should be some more experiments with this too.
Well, it could happen that you are conservative in how you change the crop, and then the person suddenly moves faster, and you could have compensated for that, but now that you've already chosen this conservative crop, you can't make up for it unless you want the frame to jump. That sort of situation.
If the person moves unexpectedly, but it will still detect this person, and the frame will move.
Yeah, but then the frame will jump, right? If you wanted to have the smoothest transition.
Yeah, when there are some, I have the videos where my friend walks like slowly on the slack line, and then he like falls down, and my algorithm processes every frame, so it was pretty smooth. Like he jumped rapidly, but I used this filtering, so even though he was like, for humans it looked like the rapid motion, for frames it was stable pretty much.
Okay, great. Thank you.
Thank you for the questions.
So if I understood this correctly, basically you always center the bounding box in each frame. Did you think about, or did you consider splitting this up in defining the bounding box for the cropping and defining a focus point? Because usually I think with humans the center of the bounding box is not the center of mass of the person, because you are wiggling around with your joints, and I think it might help if you say you always try to focus on the center of mass of the person, even if that's not the center of the bounding box, to make the image more stable over several frames.
Mm-hmm. I was thinking about using the pose key points to center the person, so that for example, the shoulders are always in the same place. But I have not yet implemented this. It sounds like a good idea. And also now I have this idea that maybe using some detection of eye movement, like where the person centers their attention, where they're looking on the video. So like in the football, it can apply it on the legs or so on. But based on the evaluation, the users told me that sometimes they don't want to see the cropped video all the time, because like in football, they just in YouTube you see these videos that it's full frame and then just cropped frame, just to bring focus, so that Gen Z don't lose their focus or whatever. And I think this can be used for the video editor, like the person who edits the video. I can process the whole video where they're just the legs, and where I feel that this moment it is that I want to have focus on the cropped legs, I can insert these frames. And also there could be an ML algorithm, I think there are some, that detects automatically what is the most interesting moment of the video where I want to bring focus for the legs, for example.
Great, thank you.
Thank you.
Thank you for your nice talk. I was wondering, did you also consider to use optical flow between images to maybe like give a user the opportunity to set how fast or how active the video should change when the bounding box or the crop box moves?
I have used optimal crop, but not for this purpose. It sounds like a good idea. Thank you. I have used optimal crop as the initial experiment with the detection. So I was thinking maybe I will not use ML at all. I would just, if I crop the videos where the person is moving, I will just detect the movement and crop the parts where the movement is located. But the problem is when you, for example, have yoga and the person stands in the downward facing dog, and then she just puts up one of her legs, the movement will be detected only on the leg. So it was not useful, but if I can determine the global movement intensity. I was also thinking about giving different stats about the video. For example, I just used the range of X and Y values to determine if it's better to use the horizontal constraints like this, or the free constraints, if the range is mostly to the X coordinate, so I just output in my program that use horizontal mode.
Okay, thank you again.
Thank you.
Sing to the beat where the pixels play, from rendering to VR, it's a pixel away.